Hi, welcome to this STAIR Tailored. My name is Sarah Powell, and I'm at the University of Texas at Austin. And today we're thinking through how we can solve two-step equations that are presented with an addition operator symbol. So for example, we're going to solve this problem right here, 2x plus 4 equals 6. And we're going to use a tool called the Algeblocks. I'll show you those in just a minute. So we're going to solve these two problems here. They are going to involve two steps because first we're thinking about like isolating the variable, and then we want to figure out the value of just x, not of 2x. So we will end up doing some division to figure out what is the value of a single x. Now, while we're doing this with the Algeblocks, we're going to emphasize two algebraic concepts. We are going to emphasize the concept of zero pairs. When I have a positive and a negative, those equal 0. They create a zero pair. And we can use zero pairs. We can create them and move them off of our mat and off of our equation space. We can also bring them in to help make the math a little bit easier. Also, in addition to our zero pairs, we have the concept of whatever you do to one side of the equal sign, you also have to do to the other. So we really want to emphasize the equal sign as a balance. That's this little symbol right here. So we'll talk about, well, if I do that to this side of the equal sign, I have to do it to that side of the equal sign as well. So let's go ahead and check out our Algeblocks and solve these two equations. So I have my problems written over here. Whenever I'm doing a problem, even if I'm using manipulatives, we want to have the abstract form of the number written here. So the first problem we're going to solve is 2x plus 4 equals 6. So let's go ahead and get this set up. Now with our Algeblocks, these little yellow rods represent the x, or the variable, and these green cubes represent the constant. Each of these has a value of 1. So we'll use our rods and our units here today to help us solve the problem, and I'll just scoot those there to the side. Now we're going to use this sentences mat because each of these equations has an equal sign, and we're going to be solving for x. And notice on this mat it has a very basic drawing of a balance to help us remember whatever we do to one side of the equation, we also have to do to the other side of the equation. So let's get this set up. I have two sets of x, so that means I have two x's, and I have 4. 1, 2, 3, 4. So I add my cubes in there, and it's positive 4. So it goes in the positive area of the mat. And that equals 6. And I'll get my 6 set up here, just like that. All right, and again, positive 6. Now we want to isolate this variable. We isolate this variable by we are going to subtract 4 from this side of the equation. That would get this to 0, but I can't just subtract 4. We have to figure out, well, what are we doing here? And there's two ways we could think about this. If I have positive 4 on this side of the mat, and I have positive 4 on that side of the mat, I could subtract 4 from both sides, all right? That is a valid thing that we can do. But it might not always be that easy. Perhaps there wouldn't be positive 4 over here to take away. So we're going to use the concept of zero pairs. So if I have positive 4 and I use negative 4, I bring that in, that would equal 0. But remember, whatever I do to one side of the equal sign, we also have to do to the other, all right? So I bring in negative 4 to this side and negative 4 to that side. Now I want to think about how I solve this equation, because I want to make sure that my concrete visual matches the abstract form of solving this problem. So let's see. First I'm going to isolate the variable, so we are deciding to subtract 4 from both sides. And look at that, that's exactly what I have set up visually. It's a very nice visual for students to understand what you're doing. And these are creating zero pairs, and if you did that to one side of the equal sign, you do that to the other side. So now let's see our zero pairs. I can create 1, 2, 3, 4 here. That would equal 0, so I'm going to remove those from my mat. And let's see, here I can create 1, 2, 3, 4 zero pairs. I also remove those from my mat. So positive 4 minus negative 4, that equals 0. I often don't write that, but 6 minus 4 is 2. So now I have 2x equals 2. And look, that's exactly what I have set up there. Now I want to solve for this x. That means I'm going to divide each of these sides by 2. So I'm going to move these into two groups, and I have two cubes there. Move those into two groups. So each x has a value of 1. X equals 1. So if I'm solving the problem just like that, I can see how to solve the problem. So x equals 1. So let's go ahead and look at this next problem here. I have 7 equals 3 plus x. So we're going to get up our 7 cubes set up on this side of the equal sign. 1, 2, 3, 4, 5, 6, 7. And that equals 1, 2, 3x plus 1. A really nice thing about using manipulatives like this is you can go around to your students and see, yes, you have this set up. 7 equals 3x plus 1. Now we are going to isolate this variable. That means I want to remove this constant and move it to the other side of the equal sign. And I can use 0 pairs to do that. So I'm going to bring in create 1 0 pair, but remember, whatever we do to that side of the equal sign, we also have to do to this side of the equal sign. So I create a 0 pair there, remove that. I create a 0 pair here and remove that. So now I have 3x equals 6. Now let's figure out what value of x, the value of a single x. So I divide these into 3 groups, and I'll divide my constants into 3 groups. So each x has a value of 2. So x equals 2. So that was an example there of how we can use those Algeblocks to help us solve 2-step equations. And I hope you'll tune into some of our other STAIR tailored videos where you can see us solve other 2-step equations and 1-step equations and all kinds of other equations. Thank you so much for tuning in.